So good morning everyone, and thank you very much for being here. Thank you also for having selected to attend our lecture. Indeed, yesterday was my birthday, and the day before yesterday was Solmeyea's birthday, and I couldn't have thought of any better way to, let's say, celebrate and also share with you our vision about having a cleaner world, having produced healthy, safe, and sustainable proteins for us all. As you may guess, I'm Vasilis, an environmental and agricultural engineer, and also the founder of Solmeyea. Solmeyea is a biotech company tackling the climate change because of CO2. Solmeyea also produces functional food and pharmaceutical ingredients by growing microalgae with the use of CO2 as a primary source of raw ingredient. So how did it all start? It all started about a decade ago during my graduate research at Columbia University. At the time, sustainability-based business models, in particularly those addressing the management of CO2, were neither in vogue nor, let's say, that up to date or so appreciated. As a result, I had to put the findings of my graduate research, let's say, on hold for a while. So instead, I worked in various business sectors, and to mention a fun fact, none of those ones had to do at all with sustainability. So having been mentored by Dr. Klaus Lackner, one of the most prominent CO2 professors of the world, I was deeply convinced there was tremendous potential in profit-making without further harming our planet. Klaus was the core advisor of Climeworks. Climeworks is a Swiss-based CO2 capturing company that just a few weeks ago raised $650 million on their fundraising round, having already attracted renowned corporate partners and clients that tangibly worry about offsetting their emissions, such as the Boston Consulting Group. So in 2019, upon my return to Greece after almost 8 years in the States, I was invited to present my graduate research at the National Technical University of Athens. Indeed, everyone loved the concept, so it was exactly at this moment I realized the time was ripe to bring Solmeyea to life. 2 years in the following, Solmeyea has managed to attract brilliant-minded biotech engineers, scientists, and business professionals coming from the Netherlands, France, the United States, Greece, India, and China, all living in Greece, all working with us, sharing the same vision, transforming the CO2 into highly demanded biomolecules. But what really bothers us, or what we try to fix, in other words, what we try to address and repair to the best of our abilities, is a double-faceted problem. On the one hand, it is a climate crisis mainly driven by the CO2, and on the other, the exponential growth in demand for food. So, looking closer, on the one hand, we have carbon penalties, offsets, and allowances. We all are aware of companies are getting fined for the excess of their business CO2 emissions. This is what we all know as carbon credits, related to the 270 billion market about the trading of those allowances. A carbon credit is a tradable certificate. More specifically, it is a permit. In other words, it's what gives the holder the right to keep on emitting carbon dioxide and greenhouse gases. Carbon credits were created as an answer to the need for controlling global carbon dioxide emissions and reducing harmful gases emitted by industrial activity. Who buys those carbon credits, though? Carbon credits are sought after by countries and companies interested in lowering their carbon footprint instead of paying all those fines. On the other hand, we see population growth and increased demand for high-quality food occurring in an environment with limited natural resources. More precisely, there is an exponential growth in demand for new sources of high-quality food. To put in another perspective, due to overpopulation and livestock revolution, there is a need for new, functional, quality ingredients to replace soy or other pea beans that we're using for our food products. In reference to market and industry structure, this double-faceted problem mentioned earlier is closely aligned with main two core key markets. On the right hand, we have a tremendous volume of CO2 coming out as part of byproducts from traditional business models. Here, almost everyone is concerned about paying fines as well as either getting rid of CO2 emissions or alternatively using the CO2 as a raw material. Second, in parallel to the management of those CO2 emissions, on the left hand, we also have the exponential growth in the demand for plant-based proteins. Our purpose. Solmeyea's production process is based on utilizing procured CO2 and not on capturing and sequestering it. This is the case because in seismogenic environments like Greece or like California, the option of dumping or storing the CO2 deep into the Earth's surface is not an option, unlike what Climeworks, as I just mentioned before, does in Switzerland and Iceland. Indeed, we transform inorganic CO2 into high-value biomolecules to produce raw materials used by the FMCG industries and make a variety of natural and healthy food, pharma, and cosmetics raw materials. How do we do it? Solmeyea fixates 29 times more CO2 than an equal size of a forest does. Technically, what we do is more intensified, sophisticated, and emphatic than what nature does. We grow microalgae relying on photosynthesis, which means that we utilize the CO2 and at the same time, combined with Greece's ample sunlight, we convert the microalgae to premium plant-based proteins and, of course, oxygen. Moreover, we grow our land upwards and not horizontally, meaning that our production tubes are vertically stacked, and as a result, we produce all the aforementioned proteins more efficiently. But then, why microalgae? Simply because they are the richest source of healthy proteins, combined with full amino acid profiles. They also come with the lowest ever allergenicity risks for any consumer who is dietary restricted due to health or due to religious reasons. Through this, we end up with full biomass valorization, given the natural resources scarcity throughout the world. So this is the most sustainable way to feed us all. Let's look at how Solmeyea and our innovation are closely aligned with the Green Deal policy, the COP26, and of course the Paris Agreement. The outcome of our process is what we produce raw materials for the food and the cosmetics industry that end up having the lowest ever environmental impact and footprint. First, we need the minimum possible land while vertically growing our algae. On top of that, we don't compete against any conventional piece of land that is arable, fertile, or useful. Instead, we use land that is non-fertile, non-arable, and cannot be used for any other purpose. Moreover, we have negative carbon footprint since we absorb and soak CO2 while photosynthesizing, meanwhile producing our microalgae biomass. And of course, we recirculate our water, which is enriched in nutrients and fertilizers, which of course can be reused for the next cycles of our microalgae intensified, let's say, growing processes. That's the big picture, Solmeyea's affiliations and the big picture as of how we perceive the concept. All in all, Solmeyea's scale-up scenario includes our role as a CO2 sponge for the heavy CO2 emitters, such as oil refineries and power plants on the bottom left part of our screen. More precisely, Solmeyea uses part of their emissions as an input for its production line, helping those heavy CO2 emitters look, act, and be greener. Having ensured that CO2-free input for us, for our photosynthetic growing phase, let's say, we grow our algae vertically in the most healthy, transparent, safe, and sustainable way. The output of proteins which we produce are highly demanded by all different industries that I mentioned before, FMCGs ranging from food, pharma, cosmetics, and feed companies for animals. That way, any corporate collaboration with Solmeyea by our affiliates, either as an input and of course as an output, tangibly helps them align their business models with the ESG criteria. Last but not least, we are also able to sell the extra carbon allowances in collaboration with the EU ETS carbon tariff system to certain businesses such as airline companies who inevitably, based on these business models, they have no other option but to keep on emitting millions of tons of CO2. How this business becomes reasonable, of course. As of now, we're just a B2B food and cosmetics ingredients provider. So our highly demanded raw materials can be used in several different plant-based food end products, ranging from plant-based meat, plant-based fish, plant-based eggs, pastry, dairy products, and of course beverages, and so on, because we have also other options. More recently, we successfully went through and completed our EU Commission's due diligence process. I'm very sorry for that. Still no? Okay, there you are, sorry. So yes, Most recently, we successfully went through and completed the EU Commission's due diligence regarding the technical and economic evaluation of our innovation and its viability. So consequently, Solmeyea attracted a number of committed food manufacturing SMEs and FMCGs who have expressed tremendous interest in our end products, further validating the functionality and quality of our microalgae ingredients. But aside from those food applications, we have the non-food applications, as mentioned earlier. And there's a great potential for Solmeyea's microalgae biomass extracts for both pharma and cosmetics industries. This is the case because our products are full of antioxidants, carotenoids, omega-3s, lipids, all plant-based and derived in a natural way. So our microalgae oil extracts and pigments can be used for post-chemotherapy drugs, nutraceuticals, cognitive function medicine improvements, and of course sunscreen and sun care anti-aging products. As of now, Solmeyea has its own private lab and offices in Athens, Greece. Solmeyea also runs its own pilot production line established at Demokritos, Greece's National Research Center. We have just been awarded the 2.5 million grant from the EU Commission. This is how we are funding our phase 1, our demo scale facility that will enable us to produce 4.5 tons of dried biomass per year, meanwhile fixating or absorbing or soaking 9 tons of CO2 at the same time through a year. Furthermore, we have secured the sale of our end products, as aforementioned, to different plant-based food and cosmetics manufacturers across Europe, and not in Greece only. Following our phase 1 demo facility, we intend to scale up our process to a phase 2 full-scale manufacturing facility. Solmeyea's factory will be built in less than 2 years from now. Our aim for phase 2 is to establish partnership with CO2 emitters located at one of Greece's delignitization regions. This would be our preferred plan because that's the way for us to get further funded both by EU and Greek state-funded programs such as the Innovation Fund and the Just Transition Fund, earmarked for underdeveloped urban regions within the EU. All this in close alignment with the ESGs and SDGs, of course. By tangibly meeting 6 out of the 17 Sustainable Development Goals, we propose a win-win case for the heavy industry CO2 emitters to make them act, look, and be greener by enabling Solmeyea act as their CO2 sponge and use their emissions as a free raw material input for their different microalgae growing phase. Aside from Solmeyea's substantiated ESG contribution to their macroeconomics, we make the CO2 emitters, all the corporations, look way much more attractive to the younger generations, who the latter ones are more conscientious, considerate, and better informed about what they eat, what they listen, what they wear, even what they follow on their social media accounts. Thanks to Solmeyea's meticulous work and undoubted professionalism, along with our team's multicultural approach, we have been awarded with an EU Commission Seal of Excellence and have successfully been through some of the most prestigious accelerator programs globally. We have certain patents in reference to the optimal CO2 use, and we are about to file an additional 2 patents in the next 50 days from now. Throughout this path, Solmeyea has built more than 60 partnerships willing to work with us and make us fulfill our dream for a greener and more optimistic world for the current and the next generations. This is our strong proposal to revitalize the rural, urban, and coastal areas, first of Greece, and then implement this to the rest of Europe by implementing our innovative technology where CO2 is trapped and reused, thus technologically acting like a microalgae production catalyst. As a consequence, Solmeyea strengthens the local, state, and EU's GDP by producing quality food and pharma proteins, which are in high demand by FMCGs. Exports innovation, has the most promising microalgae biotech hub in the southern eastern EU region, and provides jobs for both educated as well as non-specialized technicians for our phase 2 industrial scale production line. In conclusion, what I would like to retain most from my speech is that Solmeyea is an acknowledged biotech venture. Solmeyea grows certain microalgae vertically on its own efficient way. Solmeyea's efficient process can take in 29 times more CO2 than what an actual forest can absorb. And Solmeyea's B2B products are highly functional, healthier, and sustainably produced. Solmeyea's proposed synergies are designed to make our corporate affiliates look, act, and be greener. So thank you all very much for your attention.
Thank you.
Sure.
Since you came back from the US to start this venture in
Yeah.
Greece, I would be interested to hear what's sort of the biggest challenge that you faced creating a startup in the Greek sort of ecosystem, and what were some of the benefits of doing such a venture in a country like Greece?
Nice question. One of my favorite ways of approaching this answer is that each one of us is a different equation with different variables. So whatever works for me may not work for you. So family reasons brought me in Greece, to be honest. But in the meantime, you try to somehow idealize and convince yourself first and then the others that this is the right choice. So I had to come back to my comfort zone, and I knew for a fact that setting up such a demanding and cost-demanding venture will make sense to be in a country with lower expenses. So being in Greece has its benefits, but it also has several challenges. And there's a phrase I can tell only in Greek, I would say, that an ex-politician used to say, "Έξω πάμε καλύτερα." So there's a better perception from abroad, I would say, as of now. But things are getting improved also in Greece. Thankfully, because of this EU Commission's due diligence and this grant, now people understand that perception-wise, I'm not fooling anyone.
Right.
So this is it as of now, at least. Please.
Well, I find your project really great, like 29%.
29 times. 29 times.
Sorry. Yeah, 20 times what the forest does, it's just great.
Any conventional forest.
The question, is it financially profitable as of now? You had the comparison things, how much land is used, how much water is used with beef and soya.
Bravo.
And what about financial comparison?
Correct.
Is it profitable to do your project? And second, just conventionally. And second sub-question, if you take into consideration those emission bonds, so is it profitable with their consideration?
Lovely question, and thank you very much for your mindset. I like it. We're massively losing money. It is impossible for a pilot scale production process to still become profitable so far. Based on economies of scale, though, we know for a fact and based on projections that in the full scale capacity, when you have a factory, this whole concept does make sense. In other words, to further illustrate my point, just by growing microalgae in close control intensified systems and producing proteins for food is by no means efficient, because you need to compete against soy, corn, hay, starch that are massively subsidized throughout the centuries from governments. So again, against proteins you can never beat price-wise. Thankfully, microalgae by itself has a bunch of extra elements aside from the proteins. It has the lipids, the oils, it has the carotenoids, the omega-3s. Those elements, let's call them those biomolecules, are very highly demanded and appreciated from the pharma and cosmetics industry. And those profit margins can help us in total to make this concept profitable, but only on the demo scale that we're building now and on the factory. So it will become profitable, but not on this very lab pilot scale that we're working now.
Okay, it's like, let me, just short follow-up question. I mean, if it's really profitable, of course, when it will be
Bravo.
Full scale.
On a full scale.
Of course. So then you can compete now for non-governmental financing.
Yes.
You can do it as a startup and
By
get a lot of funding.
Yes.
But if it's, what you say it is, then it will be profitable. It will be also better subsidized as an ecological way.
Correct.
And you can really get a lot of funding now and not from state. And
Yes.
do your factories much faster.
I completely agree, but just so you know, for us it was kind of a dilemma. Should you go raise money day zero or should you wait a bit longer? And we tried to, let's say, make a post-doc degree on how to bootstrap in a more efficient way, to develop as much as possible a kind of a value for your own entity, let's say the venture, whatever, stake, whatever you may call it, and then go for investors. You may call it VC, private equity, whatever. So thankfully, thank God, just because of this coincidence of the EU grant project, the equity-free money is something that gives us an extra added value, the leverage, the credibility, and also the investors highly appreciate when you already have developed lab scale, pilot scale, demo scale, equity-free, and then you move on for the full-scale factory where you may be needing their kind of support. But still, even if you need their support on that scale, of the full scale, they still expect you to, if possible, bundle their contribution, whichever this amount can be, with equity-free, let's say, extra input, let's say, of money. And this particularly, and I like to highlight this innovation fund coming from the European Commission kind of, let's say, fund. It deals only exclusively with CO2. They don't care if you produce blue, produce food, produce shoes, cars. It has to be CO2. So if you act, I like to call it like a sponge of CO2, anyhow, it's good. That's what we're aiming at least.
What is your, how many square meters or hectares you need for industrial production of this?
That's also a very nice question, and thank you. Unfortunately, my slides are not that great, so on the phase 2, I just tried to illustrate that within just 6,000 square meters, you can just capture almost 500 tons of CO2. This is when you grow your algae vertically, and it is a linear analogy. So the more land you have, non-fertile, non-arable, underutilized, okay, rocky land, imagine that you cannot grow watermelons on that piece of land. So aside from growing linearly, you can grow also exponentially. How? Maybe a very reasonable question. The how gets answered because you take the CO2, in a single step process, you convert this into something which we call green glucose, that's our patent. So having those volatile fatty acids, to be more precise, can be used as an actual carbon source to grow your algae, either this way, mixotrophically, in other words, or autotrophically, but also use those VFAs, the excess of the VFAs that we're producing, to use them for fermentation. So in fermentation, you don't need excess of land because it gets assimilated way faster. So indicatively for now, 6,000 square meters, 500 tons of CO2, but the next phase doesn't presuppose that we will go and make the whole grease, let's say, green. It has to go, as I say, vertically by growing through fermenters.
When you say vertically, how high?
When I say vertically, on the BBRs, and those photobioreactors, it can go higher than 2.5 meters. You can go 10, but if you go 10, then the next row has to also be a couple of meters further, so it doesn't get shaded by the right next. So the shorter you stay, you can be also closer one next to the other. So the optimal is almost 2.5 meters. Are you covered?
For now, yes.
Okay. Please.
It's a simple question. Maybe I missed this first part. Christian Gymnast is my name. What is the investment required for the first phase to have the actual factory and everything, roughly speaking, just to get
Very roughly speaking. So just, we had those numbers.
Probably I missed the first phase.
No worries, I never mentioned the numbers so as not to further confuse you, with all due respect. So phase 1, which we just won, is going to cost us almost 1 million.
How much?
1 million is the phase 1.
Right.
The phase 1 is going to be built in the Democritus Research Center,
Right.
and this is kind of covered because of an EU grant,
Right.
which is called EIT Food. So the next scenario, the phase 2, the 6,000 square meters, is going to be needing almost 9 million. From that 9 million, we don't expect neither your or my money, with all due respect. We prefer to get projects that will get financed from Just Transition Fund, which is in Greece for the delignitization areas, as I call it, Tripoli, Megalopoli, Kozani, Ptolemaida, or combined also with the Innovation Fund from Commission.
And you think you can cover this 9 million from these grants?
You're going to cover a very certain percentage, up to 75% with those grants, and the remaining, yes, of course, you need to raise money.
So, I'm sorry to be...
Please,
because
please, please.
I'm a little bit, as a businessman...
That's how it should be.
You know,
Go ahead.
so you basically need 2.5 million euros.
Three.
Three to do this.
Correct.
And when those funds, those programs, the EU, because there is a lot of talk about the EU funds, but at the end of the day, a lot of them have not been activated.
Yes.
Are you talking about this one, Apolignytopis, which is the...
Just so, Tamio.
Have they been actually activated?
No, this is going to get activated, as you very nicely mentioned.
Yes.
With all due respect, again, I don't care that much yet, because we are building our phase 1.
Right.
And I promise, until we are ready, in 2 years from now, that this fund will be active, as you said, Just Transition Fund. But even if Just Transition Fund never ends up getting activated, we can also work with Innovation Fund.
So you get us excited, but we have to wait 1 or 2 years.
No, you can come to Democritus for this phase,
Yes.
and then you are fulfilled that this is working. The game is to make this happen first in Greece, the 6,000, and not take it outside of Greece.
You don't need money for the first...
No, this is covered, yes. We raise also money, thank God, but we also were fortunate enough to have also won this program just recently.
Very
And we don't talk about research horizon projects as you might have here from the academia. Those are different projects, programs, not horizon ones, so they're safely executed with committed industrial scale partners who are working, of course, with us and, of course, with other similar programs. But no academia. I'm trying to not
You're absolutely correct. We fully
agree and are aligned.
that. Absolutely correct.
Any more questions? Are you good? Please.
You had a slide about applications of microalgae in food.
Okay, in food, yes.
This one. And you have on the right side
The big guys.
some big guys, some very
Always those
logos.
big guys.
Can you get a little bit more
Very nice, yes.
for future collaborations or
Lovely
something already
question.
happened?
So please don't get me wrong. I can talk for hours and I'm very excited. I don't need notes for my answers, but I need to give notes for my script. So the left guys, the SMEs, are the committed existing partners who are collaborating with us on our current phase 1, the one they're going to be building in Demokritos. So the very first guy, Novamit, is a plant-based burger manufacturer in Barcelona, in Spain. The second guy is in Sweden, or Norway, Sweden. The third guy, plant-based eggs, are in France. And the fourth one is in Ceres, is a Greek company manufacturing snacks, selling zero snacks in Greece, exporting all over the world and possibly Mars, but not in Greece. So those 4 guys have already committed to buy what we'll be producing thanks to this project, finance, as we say. While growing your algae, the big guys, it takes longer for them to experiment, validate, and make sure this is working, even though they're already mature enough and they know that microalgae exists in different applications. So we already are in connections with those people from different programs we have worked with. Currently, we're working on the Mars Challenge in Israel, for instance. So those Israelis are putting us in touch with Nestle and Danone and Mondelez. So those guys are willing to start trying our products. And until they fixate their own formulations and say, oh, I like this one, and I need Vasily, let's say, to bring me this raw material coming from Greece, whatsoever, but I need a minimum threshold of 50 tons to perceive Vasily as a supplier, and Vasily is not there yet. So it takes time until they become ready, and we become capacity-wise ready to meet their expectations. But the flirt needs to start from now. So that's where we are.
Those are initial contacts.
Yeah, we have them.
Discussions.
Yes, we have no discussions to send them the very first samples. They want to start trying, and as I say, it takes forever until they become ready enough. Thank you also. I guess we're covered. Thank you very much. Thank you all. Thank you. Thanks. Thank you, Rini.